Okay, so 21 is asking us to find the absolute max, and if you want to find absolute max or absolute min, it's probably referring to the extreme value theorem. So extreme, biggest, smallest. Not just like temporarily, not local max or min, but the global max or min, or the extreme max or min, same thing. So that's what the extreme value theorem is used for, and it tells you basically you need to consider all the critical numbers. Critical numbers are relative max and mins, and sometimes relative max and mins end up being the absolute max or mins. That graph I gave you on the note page is very good at showing that. Sometimes they are and sometimes they're not. But you should also test the endpoints. So I don't know what the critical numbers are yet, but I do know the endpoints are -2 and 4. Okay, so at the ends of this graph, if I plugged in -2, I want a point, so I'm plugging it into the function. This would be -8 minus 3 times 4 plus 12, so that looks like it's -8. And if I plugged in +4, 4 times 4 times 4 is 64 minus 3 times 16 plus 12, and I don't know, this one I'm going to struggle with.
28.
It's 28.
Because 16 plus 12.
Well, you got to multiply before you add, though.
Yeah.
Oh, okay.
Yeah, because
Okay, I'm going to trust you there. I'd have to slow down on that arithmetic to feel more confident. But if I'm trying to find the absolute max value, well, I still haven't tested everything I need to, but you can see that it's at least not this one, right? -8's less than 28. 28's bigger. It's going to be closer to being the max if it's not the max. But that's just the ends of the graph. Somewhere in the middle of the graph may have gone higher and just gone down before it got to the ends. So we also have to test the critical numbers. So critical numbers are just really useful. So find the first derivative, find where the first derivative is 0 or undefined. Doesn't look like it's undefined, but it does look like it would equal 0 at 0 and 2. So extreme value theorem says test out the critical numbers, test out the endpoints. One of those will be your absolute max and one of those will be your absolute min, for sure. So if I plugged in 0, 0 minus 0 plus 12 is only 12, so this one's still bigger. And if I plugged in 2, 8 minus 12 plus 12, that would be +8. So you see how these are not bigger than this one? So the absolute max is 28, but it occurs when x is 4. So it kind of depends on what they're asking there. Again, I hope you guys look at your notes. I'm going to pull it up again real quick because this graphic, like, I've not seen a better graphic that shows that. Like, if you're trying to find the absolute max and absolute min, you got to look at the relative maxes and mins and also the endpoints, because the endpoint might be an absolute, but it might be a relative one that's an absolute. So that's all extreme value theorem says. It says you better test the endpoints because one of them might be the biggest or smallest, and you better test all the critical numbers because one of them might be the biggest or smallest. And this graphic shows you here's where it's a time where it's the biggest and here's the time where it's the smallest.